We're going to continue our Unit 2 talk on kinematics in 2 dimensions, and more specifically, full projectile motion objects. So here's a diver question that I alluded to in the previous time. A diver springs upward from a board that is 3 meters above the water. At the instant she contacts the water, her speed is 9 meters per second, and her body takes an angle of 75 with respect to the horizontal surface. Determine her initial velocity, magnitude, and direction. Okay, so we have to, there's a lot to take in here, and so again, this is why I think drawing out sometimes these problems helps us see what maybe we're missing and then have us reread the problem as we might need to. Okay, so we have a springboard, and so we'll just do a rudimentary springboard, and that it is 3 meters above the water. I'm going to draw some water in here. Okay. We will also need to know, well, we know that she goes in at 9 meters per second. Okay. At an angle of 75 to the from the horizontal. Maybe increase that magnitude of that at 9 meters per second. So determine the initial velocity. So we need the initial velocity, magnitude, and direction. Well, there are a couple things that we can utilize to help us out. And actually what we have to find is our vertical. It'd be really nice to have us find our vertical velocity, or the velocity in the y direction, because that's the one thing that can change. Now, the one thing that can't change would be the velocity in the x direction. That will help us, and we might as well, if we're going to use sine, cosine, we might as well find it for both. Now, what this is going to do is we're going to then have a velocity right before, in the y direction, right before it hits the water, right before she hits the water. We then can use that to find out what the initial velocity was of the diver, because the initial velocity on the diving board is actually going to be the same velocity coming down at that same height. Okay, so we'll be able to know that that velocity will be the same. So those will be equal. And that's where we just have to, they'll be equal but opposite in direction. So we can just kind of flip the sign on it, instead of saying that it was going at a negative, let's just say 6 meters per second. It would just be a positive 6 meters per second upwards. And in the angle at that that would be at would also be also the same, because it's falling at a different more. It's going to have that becoming more vertical as you go in. Hopefully, or that's the hope of a diver, I'm guessing. I wouldn't know. I tend to flop a lot when it comes into diving. So we have kind of those things. So we need to find the velocity in the y direction, and also it would help to have the velocity in the x direction as well. The velocity in the y direction takes our velocity times the cosine of theta, and their velocity times the sine of theta will give us the velocity in the x. I don't think I should need to show the calculations involved. Again, it always is important that we're paying attention to the that our calculators are in the degrees and not in radians. So I figure that they have a vertical velocity, or velocity in the y direction, of about 2.3, say probably 3. Yeah, small error here. Kind of ends up being a bigger error, actually, I believe. So their horizontal distance ends up becoming velocity, 2.33 meters per second. And the sine, 75 times 9 gives us a 8.693. We'll just go 7 meters per second is there. Now we're going to use that as the final velocity that it has, the diver has. We also don't have a time, so that kind of plays into and really limits maybe what equations we use. So the equation I think we should take on then would be the v sub f squared is equal to the initial velocity squared, that's what we're going to actually look for, plus 2ad, since we do actually have a distance with that. I think that would be the best route to take. We would have 8.7 squared is equal to v sub I squared, which we're actually solving for. Now here, when we would add 2, and it's going to be a negative 9.81. Now the distance traveled is also going to be negative because it's below the initial with that. So because it's below the initial, it's also going to be a negative. So we can do some of our calculations here. So 8.7 squared would give us 7, let me erase that, wrong color. Would be 75.7. That would be equal to v sub I squared plus, and then we would have 2 times negative 9.81 times a negative 3, which gives us positive 58.986. We'll just round it up to 9. We need to subtract 58.9 from both sides. So 5.7 minus 58, not divide, 58.9 gives us approximately 16.8. Need to take the square root of that to give us what we need. Take the square root of not that, but that. About 4.1. Actually, it should be negative meters per second. So now we know the initial there. Since we know also the v sub x, and this is the initial velocity in the y, we will also now be able to go and utilize the a squared plus b squared equals c squared, since we will have 4.1 squared plus 2.33 squared is equal to c squared, to give us our what c squared will actually be, because we now know two parts to our triangle. So we know the 4.1 and we know the 2.33 of our initial triangle, and that's the part that we're trying to find. With that, we can change the, kind of the direction of what that looks like. Would just flip it and just be the 2.3 there, the 4.1 there, to give us that actual initial. So 4.1 squared, which we already had, was what, 16.8. Plus 2.33 squared, 16.8. Take and that would be, oh shoot, I didn't do that, so it would be 2.23. Square root of that to give us c squared. Gives us a initial velocity of 4.7 meters per second. Now we can use tangent to find the angle at which it was launched at as well off the diving board. Utilizing again the tangent would give us that 4.1, 2.33, because SOHCAHTOA would be opposite 4.1 divided by 2.33, give us an inverse tangent of that answer to give us a launch angle at 60.4 degrees. So, which of these three punts has the longest hang time? Make sure you look at the diagram to help you answer the question. it is a common misconception to think because C has a longer projectile range, so to speak, than B or A, that it's in the air longer. But it's actually gravity that is going to affect the time that it takes for it to get to a certain height and then come back down. So because they all have the same height, they all have the same hang time. All right, let's try out another example. A ball is launched with an initial velocity of 4.47 at an angle of 66 degrees above the horizontal. What is the maximum height the ball has attained? How long did it take to return to the launch height? And what was the range? So essentially, this is a full projectile motion problem with this. And we have a lot of fun things that we get to determine through this. First, maximum height, how long, duration for the time, and range. So I'll resize some things here so we can kind of draw out what's going on. First off, we have the ball being launched at 4.47 meters per second. It has an angle of 66 degrees to the horizontal. We're asked to find the range, also known as distance in the x direction, the maximum height, which is also distance in the y direction, as well as the time that it will take. So we have a number of things that we need to solve for. But there's so much information that we still need, though. We're not really given a whole lot. So what we need to do is to, one, I always like to make sure that we have everything else accounted for. And part of that, yes, is gravity being present as well. And now that's about it. However, we can start to begin this process of, okay, this is what I'm given, not a lot, 3 knowns. So I need to start increasing the number of things that I do know. The first way I can do that is, again, utilizing some of the equations we have been given, that it is velocity in the x is equal to vi, or the initial velocity, times the cosine of theta. Velocity in the y direction, initially, that would be what it would be, times the sine of theta. Okay. Solving those will be very important because giving us a velocity in the x, because that doesn't change because we're not taking into account air resistance. That's going to be very nice because once I then find out a time, I will be able to find out the distance. The velocity in the y, especially the initial velocity in the y, will be very important because one thing that's not given to me but I should inherently know is the velocity in the y at the very top, its maximum height at that point is going to be 0 meters per second. So I then will be able to use some other things. So we start going through that process and plugging information into my calculator here. I have those velocities, I can now start to look for or kind of start going through the process. I can't use distance is equal to 1/2 gt squared yet because I don't know a time or a distance. Looking for both of those. Can't solve for two unknowns. V sub f is equal to g times t. Well, I don't know if that's going to work because your t then means that it's going to be like 10 seconds, and that might not make a lot of sense. It would solve for, because 0 v sub f is 0 and gravity is negative 9.81, but 0 divided by 9.81, well, there you go. You got 0. Time shouldn't be 0. So you're looking for those things, and so what you come up with is that the only equation that you can use at this time is v sub f, and especially in the y, squared is equal to v sub iy or yiy. Either way, it doesn't matter too much. Plus 2 times gravity times the change in distance. Technically, it's change in distance. And more specifically, we'll say change in distance in the y. We know the velocity is going to be 0. We just solved for our initial velocity. I also have two times gravity. Yep. Times the distance in the y direction. Solving for what I have, 0 squared is going to be just a 0, which is going to be really nice, is equal to 4.08 squared, or about 16 point, and we'll round it as for calculation purposes. That would be actually meter squared, second squared, plus, and then we have our 9.81 times 2, which ends up being actually a negative 19.62 distance in the y direction. We have to rearrange some things. So we would have a negative 16.65. So yeah, because I needed to subtract both sides by that to get rid of it, which will then equal a negative 19.62 times d sub y. I need to get that by itself. So I take my 16.65 and divide it by 19.62. The negatives cancel out to equal that positive. And I get a d sub y those technically should be meters per second squared, not meters squared. So that d sub y about 0.8, let's go 85 meters. It's not very high. So there we have our maximum height. Now we can solve for t, which we can utilize. Now we can utilize an equation that to solve for t, in that distance in the y direction is equal to 1/2 gt squared solving for what I know, 0.85 meters is equal to 1/2 of 9.81, which we solve for quite often. So a lot of times students start actually remembering it. And that it would be 4.905. And that would be meters per second squared times t squared. Divide our 0.85 by 4.905 meters per second squared to equal t, so they would cancel out on both sides. And I get a time, and here becomes the trick, or I get 0.173 seconds squared is equal to t squared. Take the square root of that. To get a time of 0.42 seconds is equal to t. Now, here's the thing, and this is what where a lot of people forget, is that that time that we just found is to get to this point. We still need to find the time that it takes to go down to the other side. which means we have to double the time. So we need to multiply it by 2 to get the full time, not just the time to the maximum, but the time to the maximum and then drop back down. So multiplying that by 2 will give me a time of 0.833 seconds. Now that we have a time, we can utilize the equation. Distance in the x is equal to velocity in the x times time, giving us 0.833 times the time that we solved for earlier, or the velocity that we solved for earlier, 0.82. Multiplying those together gives us a distance in the x of 1.52 meters. There are I've seen equations out there for like, solve for range specifically for certain things. I like going through the process, especially, very rarely are you going to ever ask for what is the range, because this would be a lot of work just to solve for range, and therefore sometimes using those equations would work. Ultimately, all those big equations that are solved, like solve this complex equation for it, you're going to look at the equation and go, how did they get that here and how did they get that there? It all comes down to some trigonometric proofs that would happen if you just start combining all of these equations that ultimately we did. As some of you are kind of maybe starting to see some of that, that's what ends up happening, is that the equations start getting compiled, and through some trigonometric proofs you can start canceling some things out. Through algebra you can start canceling some things out, but ultimately you're doing the same work. The end of Unit 2 and two-dimensional kinematics. Being and going through doing some more practices, and that's why sometimes we have more practice problems, and those practice problems would be very beneficial to solve through as they give us more and more practice.